So, welcome you all once again for the concrete technology course. So, last class we have discussed what are the bogies compounds, different bogies compounds. So, there are four bogies compounds, and we have discussed what is the effect of those bogies compounds on the cement, right? So, today we'll see what are the different tests on cement, right? So we are having a field test as well as the laboratory test for the cement. So first of all, we need to check. So if you want to prepare a concrete, so you should test before making concrete those materials, whatever we are using in the concrete. So those are cement, fine aggregate, coarse aggregate, and water. So first of all, we need to check whether those materials are in as per the IS recommendations or not. So we have different tests on cement. So in the field also we can test, and in the laboratory also we can test. And similarly for the aggregates, we have different tests to confirm the IS recommendations. So similarly for the water, so we need to have a potable water. So the water test also is available as per the IS codal provisions, right? So today we'll see the test on cement. So while discussing in aggregates, we'll see what are the different tests on aggregates and water. So for time being, we are in cement. So we are discussing first module. So we'll see the tests on cement, different tests on cement, right? So testing of cement. So mainly we have two categories of tests on cement. So first one is field testing, and the second one is laboratory testing. Field testing and laboratory testing. So field testing is very important because we are using the cement to make the concrete. We are using the cement in the site itself, right? So laboratory, before producing the cement, they will test. So laboratory tests, right? So these field tests are very, very important, especially for the site conditions. So whether the cement, whatever we are getting to the site, so they are in the norms or not, that we need to check it. So apart from the field test, we need to have a laboratory test in the field itself. So we have some tests. So even the producing before transporting the cement, so in the cement factory itself, they will test all the tests, and they will pass through the recommendations. Then only they will produce the cement. So apart from the cement, apart from this, so in the site, while mixing the concrete, so we need to test it. We need to test the cement. So different tests. So these two are the different categories for the cement test. So first one is field testing, and the second one is laboratory testing. So what is field testing? How to check the cement in the field? How to check the cement in the field, and what are the different tests available for the laboratory? So laboratory, what test we need to do for the cement, confirming as per the IS codal provisions, Indian standards. So first we'll see the field testing, how to do field testing. So the following are the field tests. So field tests, we have 5 different types of tests in the field. So first and foremost thing, just open a bag. So if you receive the cement, so you will receive the 50 kg bag, then open the bag. Okay, you should have a good look. At the cement, and there should not be any lumps. In the bag. So lumps are not allowed in the no. If the lumps are present in the cement, so we have to reject that entire bag. So there should not be any visible lumps, and the color of the cement should be normally greenish gray. The color should be greenish gray, and it should not be any visible lumps. Once if you open the cement bag, you should see these two. So should not be any visible lumps, and the cement looks normally greenish gray color, right? So this is the first and foremost thing in the field test. And the second one is to trust your hand and into cement bag, and it must give a cool feeling. So just dip your entire hand in the cement bag. It should give cool feeling. It should give cool feeling. Then only you can say it's a good cement. And there should not be any lumps inside. So in the first step, we will see just outside whether any lumps are there. Once you dip the your hand into the cement, it should have a cool feeling, and there should not be any lumps inside. So there should not be any lumps inside. So this is the second test. And the third one, take a pinch of cement. Take a pinch of cement and feel between the figures. Take a pinch of cement and feel between the figures. So it should be a smooth and non-gritty feeling. So it should have a smooth feeling. It should have a smooth feeling. Since cement is very finer material, it should have a very smooth, feeling. Smooth feeling, not a gritty feeling. So this is the third test what we can do in cement. The fourth one, take a handful of cement. Take a handful of cement. Take some a handful of cement and throw it in a bucket, with full of water. Bucket with full of water. So the particles should float. The cement particle should float on the water. Should float on the water for some time before they sink. So it has to float. To float, float is very, very important. So the cement particle should float on the bucket of water, right? So then you can say that before sinking, they have to float. After that, they will absorb the water and it will sink, right? So this is the fourth test what we need to do in field. And the fifth one, take 100 grams of cement. Take 100 grams of cement and a small quantity of water. Make a stiff paste. So from this stiff paste, pat a cake. So pat a cake with the sharp edges. Put it on the glass plate and slowly take it underwater in a bucket. So we have to make the paste. Take 100 grams of cement and a small quantity of water. Make the paste, and from this stiff paste, take a small pat a cake, and put this cake into a glass plate. Put this small cake into a glass plate and slowly dip into the water in a bucket. Slowly dip into water in a bucket. See that the shape of the cake is not disturbed. While taking it down in the bottom of the bucket. You should not disturb the shape. Shape should be there, right? So slowly dip the entire cement cake into bottom of the water, and you should see that the cake shape should not disturb. After 24 hours, the cake should retain its original shape. And at the same time, it should also set and attain some strength. So why this attain some strength? So previous class we have discussed the hydration process, right? So once if you mix water with the cement, the hydration process will take place. Right? So definitely the cement should gain the strength after 24 hours. Why? Because you are putting cement paste into a water. You are dipping an entire paste into a water. It has to get the strength. Some strength. So we are keeping 24 hours. So it has to get the strength. So these are the 5 different tests we can do it in the field. So these are not laboratory tests. These are the field tests. So once again, we'll see the first one is open the bag and see that whether it is a good look of the cement or not, and the color should be greenish gray. And the second one, So thrust your hand into the cement bag, and you should feel cool feeling. You should feel a cool feeling in the inside the bag, and you should see that the lumps are not there inside. And take a pinch of cement and between the fingers, just see that. So you have to get a very smooth feeling, very smooth feeling. This is the third one, and the fourth one is take a handful of cement and throw it in a bucket of water. Throw it in a bucket of water. The cement particle has to flow. The cement particles has to flow on the water before it sinks. And then take 100 grams of cement, the fifth one, 100 grams of cement, add some water, make a paste, and take a small quantity of water, put it in a glass plate, and dip the glass plate into a bucket of water slowly to the bottom, and see that the cake, whatever cement cake, so it should not disturb the shape, and after 24 hours, it has to gain the strength, some strength. After 24 hours, it has to gain some strength, right? So there are the five different tests. Five different tests we can perform in the field. So next is the laboratory testing. So these are the six tests we can do it in laboratory. So the first one is fineness of test, fineness of the cement. So that we need to test it. And the second one is setting time. So setting time we have two types. So we have initial setting time and final setting time. So strength test we should have the strength test. The compressive strength especially. So compressive strength of the cement we can find out by using this strength test. And soundness test. Yes, we have to do soundness test by using lead chatelier apparatus. And the heat of hydration. So we have to check the heat of hydration also. And what are the chemical composition tests? So these are the six different types of tests we can do it in laboratory. So we'll see one by one. So what is the fineness, how to do the fineness test, and how to do the setting time, right? So we'll see first fineness of the cement test. So fineness of the cement test. So we should know what is the fineness of the cement. Cement is very fine things. Particles are very, very fine. So we need to test it. So we need to find what is the fineness of the cement. The fineness of the cement has an important bearing on the rate of hydration, and hence the rate of gain of strength, and also the rate of evolution of heat. So this is directly proportional. The fineness of the cement is directly proportional to the gain of strength and evolution of the heat. The fineness is more, so we get the rate of strength, gain strength is very fast, and the rate of evolution also will have the very fast. Finer cement offers a greater surface area. The finer cements, cement is very fine, so it is having greater surface area for hydration, and hence faster the development of the cement. So strength. So that's what I told you in the previous point. So once the cement is having finer and finer, so it is having greater surface area for the hydration, and it is give very faster development of the strength. Faster development of the strength. If the cement is not finer, so surface area will be very less. The hydration process will have slow, and the development of the strength is also late. So different types of cements are ground to different fineness. So we have different types of cements. Already we have discussed what are the different types of cement. So different cements are having different fineness. So based on the usage, so they have defined this different fineness of the cement. The disadvantage of fine grinding, that it is susceptible to air set and air leak radiation. So this is the only disadvantage of the cement if it is having very, very fine grinding. So it is susceptible to air set and early deterioration. So we should have some value, right? So those value as per the recommendations, we need to test it, right? So the maximum number of particles in a cement sample should have the size less than 100 micron. should have the less than 100 microns. The smallest particle may have the size about 1.5 micron. So this is the particle size. This is the particle size. So all the particles, sample, cement, whatever we are taking for the fineness should have a size less than 100 microns. And the smallest particle may have the size of 1.5 microns. So the particle size fraction below 3 microns have been found and have predominant effect on strength at 1 day, while 3 to 25 fraction has the major influence on 28-day strength. So the particles having 3 microns have the predominant in 1 day strength, and the particle size having 3 to 25 particle size having 3 to 25 fraction, it is having major influence on 28 days strength. So increase in fineness of cement is also found increase in drying shrinkage in the current. So if the fineness is increased, fineness of the cement is increased, so it is found to be an increase in drying shrinkage of the concrete also. So fineness of the cement we can find out in two ways. So first one is by sieving. So by sieving we can find out the fineness of the cement, and the second one is the determination of specific surface. Determination of specific surface. So this total surface area of all the particles in 1 gram of cement by air permeability apparatus. So we can use to find the specific surface of the cement by using air permeability apparatus, and it is expressed in cm square per gram, centimeter square per gram of cement. So this is specific surface area. So we can use air permeability apparatus and or Blaine's air permeability apparatus. So the maximum cases in India, we are using Blaine's air permeability apparatus to find the specific surface area of the cement, right? So we'll see one by one by sieving how to perform the test by sieving. So sieve test. So weigh correctly 100 grams of cement. So take 100 grams of cement, standard sieve number, ISU number 9, so 90 micron sieve. So take 100 grams of cement and put in the standard sieve, 90 micron sieve. So break down the air set lumps in the sample with finger. So if there is in the 100 grams of sample, whatever we have taken, so if there is any lumps, small air set lumps will be there, right? So those lumps, make it a breakdown by using your fingers, right? Continuously sieve the sample and give a circular vertical motion for a period of 15 minutes. So take 90 micron sieve, put the sample of 100 grams on this on sieve and set the air. If there is any lumps are there, so press with finger and break down all the lumps and sieve these 90 micron sieve for 15 minutes. So give circular and vertical motion for 15 minutes. So we can use the mechanical sieving devices. So mechanical devices also we can use. So basically we need to give a circular motion as well as the vertical motion for 15 minutes and wait the residue left over on the sieve. So wait the residue on the leftover on the sieve. So whatever on the sieve, whatever residue is there, just wait, take the weight of the residue. So this weight shall not exceed 10% of ordinary cement. 10% of ordinary cement. So sieve tests are rarely used. So these tests will have the rarely used for the cement test, especially for the fineness. So this weight should not exceed. The weight should not exceed 10% of the ordinary cement. 10% of the ordinary cement. So this is about sieve test. So by using sieving, So we can find out the fineness of the cement. So next one is air permeability test. Air permeability method. How to find the specific surface area of the cement particles. Specific surface area of the cement particles. So we can use air permeability apparatus, or Blaine's air permeability apparatus. So this is the Blaine's air permeability apparatus. This is the Blaine's air permeability apparatus. So this is the Blaine's air permeability apparatus. So by using this, we can find out the specific surface area of the cement, or we can use air permeability apparatus. So that we will see in the next slide. So this method of test covers the procedure for determining the fineness of the cement as represented by specific surface. So specific surface expressed in total surface area in square centimeters per gram the cement, and it is also expressed in terms of meter square per kg. So if we take per kg of cement, what is the surface area? Surface area means the meter square. So meter square per kg or centimeter square per gram. So we can express in both the units. The principle based on the relation between the flow of air. The principle is based on the relation between the flow of air through the cement, bed, and the surface of particles comprising on the cement bed, So this is the main principle behind this air permeability method. The principle is based on the relation between the flow of air through the cement bed and the surface area of the particles comprising in the cement bed. So from this, the specific area per unit weight of the body material can be related to the permeability of bed of a given porosity. So this is the main the principle behind air permeability method. So this is the air permeability apparatus. So we can see the cement bed here. So cement bed here and a permeability cell. So dry air will pass the air from here, and we'll have these two manometers to find out the pressure. So they are the manometers. So we have to find the H1 and H2. So that we will see. See here, capillary tube. So we'll have the capillary tube and the flow meter. So this is the air permeability apparatus we use for the test. So the cement bed in permeability cell is 1 centimeter height. 1 centimeter height. So this is having 1 centimeter height and 2.5 centimeters in diameter. 1 centimeter height and 2.5 centimeters in diameter. So knowing the density of the cement, the weight required to make the cement bed of a porosity is 0.475 can be calculated. So you can calculate the density of the, once we know density of the cement, so how much cement is required for the cement bed for the porosity 0.475 you can calculate. So this quantity of the cement is placed in the permeability cell. So the quantity whatever we have calculated in this step, so we have to place the quantity of cement placed in the permeability cell in a standard manner and slowly pass the air through the cement bed through the cement. So we have to pass the air through a cement bed with a constant velocity, right? So velocity should also you have to maintain, because the particle, if you have a very high velocity, if you put a high velocity, all the cement particles will blow away from the to the air, right? So we should maintain the velocity so that it will pass the air through the cement bed. So adjust the rate of airflow until the flow meter shows the difference of levels 30 to 50 centimeters. So this is important. So you have to flow meter you have to adjust the rate of airflow until the flow meter shows the difference of levels of 30 to 50 centimeters. So read the difference in levels H1 and H2 of the manometers and flow meters, right? So repeat the observations. So repeat the observations to ensure that the study conditions have been obtained and shown in as constant value of H1 by H2. H1 by H2, and a specific surface SW is calculated by using this formula. We can calculate by using this formula. So SW equal to K into under root H1 by H2, and the K value is 14 by d into 1 minus epsilon under root epsilon cube A by CL. So which is here. So epsilon eta is porosity, so 0.475, and A is the area of cement bed, and L is the length of the cement bed, and D is the density of the cement, and C is the flow meter constant. So by using this formula, we can find the specific surface of the cement, right? So this is one more test, standard consistency test. So this test we have not listed in the laboratory test, but we have listed the setting time, right? We have listed the setting time. For this setting time, I already told you the setting time we have two types. One is initial setting time, and other one is final setting time. To know the setting time, we have to make the cement for a consistency. Consistency cement paste is required to know the initial setting time as well as the final setting time. For that, we have to conduct this standard consistency test. So this is very, very important. Standard consistency test is very important. So especially we will find the water cement ratio. So this consistency for water cement, we can find out the water cement ratio for the by using this test, standard consistency test, right? So for this test, we have to use the Wacat apparatus. We have to use the Wacat apparatus with plunger, Wacat apparatus with plunger of 10 mm diameter and 50 mm length. Plunger of 10 mm diameter and 50 mm in length, and it has to penetrate 30 to 35 mm from the top of the mold. So this is called Wacat apparatus. So even for the initial setting time and final setting time, we have to use the Wacat apparatus. The same apparatus we can use. So instead of plunger, so plunger we will use for the consistency test, and for initial setting time we have to use the needle. We have to use the two different needles. For the initial setting time one needle, and final setting time one needle we need to use, right? So this is the Wacat apparatus. We'll have the mold. So we have to take the sample. With this mold, and this is the plunger. So this is the plunger. So that's what we have discussed, and this is the needle for initial setting. Needle for the initial setting time. So this needle we will use for the final setting time. So the same apparatus we need to use. We will use for standard consistency, initial setting time, and final setting time. And a glass plate. So glass plate is required here. So this is a glass plate, and this is a mold, and this is the. So we need to place the plunger here, right? So we need to fix the plunger here, and then we need to touch it. So this is the Wacat apparatus we will use for the standard consistency, initial setting time, and final setting time. So this is a procedure we will for standard consistency. So this is plunger. This is the plunger. So this plunger is having 10 10 mm diameter and 50 mm is length. So take about 500 grams of cement. Take the sample 500 grams of the cement and prepare a paste. And prepare a paste with weighed quantity of water. So, for example, you can say that 24% by weight of cement. 24% by weight of cement for the first trial. For the first trial, so take the 500 grams of cement. So if you take the 500 grams of cement, 24% of this 500 grams, take the water and mix it thoroughly, the paste. So this paste must be prepared in a standard manner and filled into a vacat mold. So this is the mold. Vacat mold. So this is the mold. So we have to fill the this paste into the vacat mold within 3 to 5 minutes. Within 3 to 5 minutes, we have to fill it on the vacat mold. So after completely filling in the mold, well, shake well to expel the air. Also, if there is any air lumps are there in the mold, so you have to shake the mold and you have to expel the air. So then a standard plunger of 10 mm diameter and 50 mm long is attached and brought it down to touch the surface of the paste. Brought it down and to touch the surface of the paste on a test block and quickly released, allowing it to sink into the paste by its own weight. So you have to release the plunger, quick release of the plunger, and allow the plunger to sink into the paste by its own weight. So take the reading. Note down the reading, how much penetration has been happened, and conduct the second trial. So use 25%. Use 25% of water and find out the depth of penetration. So these trials we need to do continuously unless you achieve the value of 33 to 35 mm. 33 to 35 mm from the top. So the plunger has to penetrate into the mold about 33 to 35 mm. So we have to do, it's a continuous process. So first trial we have taken 24%, second trial 25%, and third trial 20, 26, 27, 28. So like that we have to do the different trials, right? At that particular percentage of water which allows the plunger to penetrate only the depth of 33 to 35 mm. So in a particular point of time, and particular point of water percentage, okay, the plunger penetrate only 33 to 35 mm from the top. So that is known as percentage of water. Required to produce cement paste of standard consistency. That is called the standard water percentage of water required to produce a cement paste of standard consistency. So this percentage is usually denoted by P. So the test required to be conducted at a constant temperature. So we have to see that the temperature, room temperature, we need to conduct this test, right? The humidity should be 90%. So this is how you have to do the standard consistency test, right? So simple, take 500 grams of cement and take 24% of weight of cement. Take the water and mix it thoroughly, and fill the mold, vacat mold, and shake the vacat mold, to go the air sets. So then put the entire mold into the vacat apparatus and attach the plunger. So brought down the plunger to the surface of the cement paste, and release the plunger quickly. The plunger has to penetrate into the cement paste, by its own weight, So repeat the process until the plunger reaches the 33 to 35 of penetration, right? So the percentage of water required for that point, the plunger penetrates 33 to 35 So that percentage of water is called the water required to produce cement paste in a standard consistency, and this will be denoted as P. And this test we need to do it in room temperature, and the humidity is 90%. Constant humidity we need to do it, right? So this is about standard consistency. So this is the that's what all the measurements given in this figure. Vacat apparatus, the cement mold, and the plunger, and this is for final setting time, and this is the needle, right? So this is the front view, and this is the side view of the Vacat apparatus, right? So thank you very much for your attention. So especially in this class, we have discussed tests on cement. So two different tests. So we have field test and the laboratory test. The field test, how to check the cement in the field, whether it is a good cement or not. So the thing we have discussed, and the laboratory test, we have six different types of tests. So in the six tests we have discussed the uh, first one first test, fineness of the cement, how to find the fineness of cement by using sieve analysis, sieving, and by using air permeability test. And the second one, setting time. The setting time before doing the experimental setting time. So first of all, we need to know what is the standard consistency of cement. So how to find the standard consistency of the cement. So that we have discussed in this lecture. And then the next lecture we will discuss about how to do the initial setting time and how to do the final setting time and the remaining tests, how to perform the remaining tests in the laboratory. Right. So thank you very much for your attention.
Like, share, and subscribe. Hit the bell icon for more updates.